and start the session. Awesome, folks. Thank you, thank you for joining. Another session from AppliedAI Club. I think this is session number 48 or 49. So some of you are new, as we just discussed before. So I'll give a brief introduction about the community itself. So we are part of AppliedAI Club. It's an open community mostly for AI practitioners. We've been running this over the last years. So the primary things we do is a couple of things. Number one is we create these weekly free sessions on how people can actually work and learn about AI. Typically, we have an expert joining us every single week, and they talk to us about a specific topic around AI. All these sessions are free, and we have all the past recordings available on YouTube. There are some very, very interesting sessions if you're interested in checking them out, right? The second thing is we occasionally run these study groups. Study groups are a learning mechanism where we give out specific topics and self-learning material. The community members join those study groups, build the products by themselves as a way of, while doing that, they also learn how to work with these tools and kind of like get better. So that's the second part of it. We also have a active community. So we have about 2,200 folks in the overall community and about 500 people in our WhatsApp groups, where most of the ad hoc discussions actually happen. It's a fairly active place, and if you are interested in being part of it, just explore that. I'll drop the link to joining the community in the chat in a bit. Okay, so coming to today's session. So today's session is on vision AI models. So vision AI is something that we've been wanting to do for a while, and Abheetha here, who is going to be the presenter, she's a long-term member of the community. She's also a volunteer for the community. She helps us quite a bit in setting up some of getting some of the work actually, or running the community itself. She's also a product manager at Gumbo Tech, and she has deep expertise coming from both the engineering world and also in the product world on dealing with vision AI, especially focused on OCR and documents. Right, so that's what we're actually going to see today. Before I hand it over to Abheetha, a couple of housekeeping stuff. This session is being recorded, so we are going to edit it and put it up on YouTube in a couple of days. So if you don't want certain material to be shared, just let us know. Number two is we will take questions towards the end, probably the last 10 minutes. So if you have any questions, I would request you put it up in the chat so that we can actually pick it up. Okay. Yeah. Abheetha, thank you so much for doing this. Over to you.
Yeah, sure, Bala. So, yeah, hi guys. Thanks for joining on a Saturday so early. So I have been studying computer vision in general since my college years back in 2020. So it is very beautiful to see how things have evolved in this landscape, from simple CNNs and ResNet architectures to multimodal LLMs that can process all kinds of visual information, from text to image to videos. So so I'm quite passionate about this journey. So I come from an engineering background, and I have had to work with computer vision models while I was working as an engineer as well. I've used models like YOLO and for object detection and stuff. So it's really nice to explore the LLMs, vision language models that have the capabilities to do beyond just object detection. So yeah, let me just start my presentation. I'm just going to share my screen. You can let me know if it is visible. So
yeah, we can see it now.
Yeah. So the thing is, the topic is vision language models, but most of the tools are already like multimodal. There's a component of vision in all the models that we know, from Gemini to Claude to ChatGPT and other open source models like Qwen as well. So just a second. So a little bit on the timeline of what has happened in the world of vision, right? So you had CNNs and ResNet in around 2012, 2015, a lot of deep convolution networks. It could do stuff like object detection, and it worked on principles like image segmentation, object detection with drawing bounding boxes, things like this. And in 2017 was the breakthrough from Google with the attention is all you need paper, and transformers were introduced. So after that, what happened was we had innovations like Clip from OpenAI, which basically could do a little more than just object detection. It could it could basically relate text to text and images, and it could do stuff like image captioning, retrieval, visual QA. They followed dual encoders, NLP-based projection layers. And in around 2023, you had GPT-4V, Gemini, that could, these were LLMs that could reason over images and text as well. So now, and then in 2024, we had other models like Qwen3-VL, intern VL as well. I will come to a little bit exactly what these models were in the next slides. So yeah, just wait for that. So now we have paradigms like ChatGPT 5, Qwen3-VL, Gemini 3. They are completely natively multimodal, and they can do deep visual reasoning, and they can also do execute on tasks as well. So I want to give a brief of how we've evolved in the architectural landscape. So one of the important architectures was of Clip. So the idea behind it was contrastive pre-training. What it did was it would follow a dual encoder setup. It had two layers. It had a text encoder and an image encoder. And what it would do was this would map to a shared mathematical space, and the classification depended on a similarity scoring. It basically meant, it would basically do similarity scoring of if basically if the image vector that was ingested and the prompt vector, if they how much ever closely they aligned, that was what it predicted. So this was very important because it enabled something called zero-shot classification, which was the ability to classify images which were specifically not seen during training. So it worked by comparing image embeddings with text embeddings of potential labels in a shared space and selecting the label with the highest similarity without requiring any kind of retraining. So this was the system Clip basically used, and it followed a dual encoding architecture, followed similarity matching, and it was simple cosine similarity. Then I want to discuss about Qwen3-VL. So this was released around 2025 in November. It's by Alibaba and it is open source. So Alibaba has released a lot more Qwen3-VL models, but I wanted to discuss about this in particular because this is a vision-specific model. So what it means is it has 235 billion parameters, of which only 22 billion are activated, and it follows a mixture of experts architecture. So what that means is, just a second. Yeah. So what that means is you had in the architecture, what it does is you have inputs, which could be text and image and videos. So they're all converted into tokens. And what happens is there is a pre-processing interleaving layer. There is a vision encoder initially, and after it ingests the vision tokens, it goes to a unified transformer backbone. So all the tokens of text, image, and video are all unified into directly onto the transformer layer. And after that, based on what kind of querying you have done, it also reroutes to an expert. It could it might have different kind of experts that it will fetch based on the query that you have done. If there was a expert for, say, documents, then it might fetch something like that. If it is for more reasoning and mathematical, it might fetch an expert for mathematical analysis. So something like that. And what it particularly uses is another highlight is it has something called multimodal rotatory positional embeddings. And this is important because it assigns 3D coordinates to data, because it also processes videos than just text in 1D sequence or images in 2D sequences. It also uses 3D coordinates. It can also assign 3D coordinates to data and map it, and this enables spatial awareness. So yeah, beyond this, you have outputs of either text generation or other specific outputs based on your query. It could be to do OCR, process documents, pass documents, or do other actions like UI navigation as well. So up next, so Gemini 3 Pro also kind of has the similar setup, except the difference in Gemini is that in Qwen3 there is still a vision encoder layer, and it achieves unified shared vector space through interleaving. But in Gemini, you have a true native multimodality. All the training that goes through in Gemini. It ingests all kinds of multimodal inputs in the same space. It ingests everything in the same space, and that is directly fed to the transformers. And in Qwen3, you have, if you want to toggle between think and instruct modes, you have to, there's endpoints to toggle for that. But Gemini 3 Pro has adaptive reasoning engine, so it can understand based on what kind of context you need and adaptively reason for it. So, and GPT-5, what it does is it is kind of better at answering why something is happening in a video, and it integrates natively with Sora, and it not only understands video, but also suggests edits or generates synthetic variations of what it sees. And Claude is trained more for something like UI navigation, because it had a lot of emphasis on web development and things like that. So it understands anything related to UI navigation a lot better, as we have seen in stuff like OpenClaw as well. So, but Gemini 3 Pro is one of the best tools for processing videos and all of that currently. And the competitor for that, which is open, is also Qwen3-VL. So yeah, and so the thing is, you can basically parse a large number of documents with LLMs as well as traditional OCR right now. So LLMs have the capability to basically ingest a lot, and because it ingests all the there's also one more thing that I have missed here, which is usually in normal earlier versions of computer vision technologies, when you ingested images or videos or something, it would kind of compress the image. If you uploaded some 500 is to 500 image, it would kind of compress it to a particular format. In fact, clip requires a certain specific aspect ratio and all for for it to ingest data. But with the newer models, there is something called dynamic tiling that is done, which means just as text is broken down into tokens, images are also broken down into smaller patches. So this enables LLMs to not lose data. Because traditional OCR and traditional computer vision kind of compresses, it can lose out on some patches of data, but LLMs kind of don't lose that data. So that is one thing to keep in mind. But the question is, why do you still need traditional OCR, and do LLMs outperform OCR systems? The answer is OCR works in the context of structured documents very well. For example, if you have like a receipt, and the mathematics behind it is it draws bounding boxes across all the detected edges, and then it recognizes the characters and outputs it. So it outperforms in documents where you know exactly what the structure is, and because it's still traditional OCR, it does not require high performance GPUs, and it can run on simple CPUs as well. And whereas VLMs might require a lot of GPU clusters, and the cost is a lot more. So if you have like a deterministic workflow, then go for traditional OCR. Or else, if you feed it to VLMs still complete tokens for you. So it predicts the next token. So if there is say a character missing, or if it detects something like that, it might hallucinate a number that is not going to be correct for your workflow. So yeah, one more use cases for edge and offline deployment. So traditional OCR can fit into a small 50 MB of RAM and can natively run on low power ARM chips without an internet connection. So if that is your use case, go for that as well. So yeah, the question is, what do we do from now onwards, right? So the trend has been, as I mentioned, we had CNNs, then you had dual-encoder setups, which means that you did not have the tokens were not fed directly to the LLMs initially, and they did not share a space. And you also actually had other tools as well, which I think I didn't cover, like Blip and Flamingo. What what it did was it would apart from using a dual, instead of using a dual architecture like one text encoder and one vision encoder, there would be a vision encoder, and that would that would project directly to a LLM. So the LLM would actually not ingest the image tokens, but it would only understand the projection it got from the visual encoder. So that is over here, which was called like the adapter architecture. And then you have native multimodal transformers now, where everything is natively trained on text, image, videos, audios, everything. And what it still cannot do is complete, 3D scene representation. It can do to a certain extent. There are tools which are used in medical imaging, like VScan, and Gemma 3 can also do spatial, representation to a certain extent, but they're not completely great, because the training itself is not done on enough spatial data. So a lot of the data that is used to train is videos and images and text. So yeah. So what we can see emerging is structured world models, where it can basically understand the world state itself. And then afterwards, it can be further embodied into robotics, and which requires not just understanding your world state, but also performing actions on it. So when LLMs can hit simulation as well, that is when we can see a great development in that. Now I have some production use cases by certain companies. So these are examples of various pipelines that companies adopted to perform some certain tasks, right? So Pinterest created recently something called pin landing, which was solving a challenge of traditional keyword landing pages. So the idea is that users search something on the platform, and that is later ingested as topics, and topics are created based on user behavior. So it involved manual curation of search logs. But the problem was this would limit the actual topics that can be covered in the entire app. So instead of deriving topics from user behavior, they created a multi-stage pipeline combining a VLM for attribute extraction. And then they plugged, once they got the attributes, so for example, if you have an image, VLMs were used to get attributes of the image. It would generate the attributes of, this is, for example, a silk dress, the color of the dress, and something like that. And once the attributes were extracted, it was plugged into an LLM for topic generation. So it would refine that into a proper topic. And after that, a clip-based dual-encoder architecture was used for content matching. So what happened is you got your attribute set, and then once you got that, this would plug into clip, which was good at content matching, because it's just going to look at what was the description of the text prompt, and it matches that to the image with similarity scores. So
sorry, there is a question on Pinterest. Can you restate the problem statement for Pinterest?
Sure. So the problem statement was, if you've used Pinterest, you basically go and you search for a particular image, and that is characterized as a user behavior searching with some particular intent. Say if you search for a green dress, it would generate, you would have to manually curate those topics like a green dress and add it to your topics manually. But with this, LLMs, what you do is you already have a large repository of images that are already present on your platform. So you actually go through your images on your own platform and generate these topics automatically without depending on users to search, if that makes it clear. Does that make it clear?
Is this to ensure that the customers find what they want, like into the search?
Yes. Okay. So what that happens is your content discovery improves a lot. So people can actually again search something and find very specific content matching as well. So your content discovery improves, personalized recommendations improves, and you also improve your scale of topic coverage. So that is the idea. Hope that is clear. The second use case was with Instacart. Now I added this use case because they actually had quite a long pipeline of using very traditional computer vision techniques like segmentation, OCR, as well as LLMs, using LLMs. So what Instacart is it's an online grocery delivery and pickup service, and it lets customers order groceries from local stores directly. Unlike Swiggy and Instamart that we have, there are dark stores. They don't have dark stores. They connect to local stores directly. And these orders are fulfilled by personal shoppers. So the platform recently launched digital flyers, and retailers on the platform could upload their weekly and monthly promotions. So promotions could be basically they promote what kind of offers they have, what kind of deals they have, and they can upload this onto the platform. So this enabled the customers to browse weekly deals from their favorite retailers. But the problem was since when retailers uploaded these digital flyers, Instacart had to sit and map what are the offers for that particular retailer on what items. They had to sit and catalog that manually, and it was super time consuming. So what they did was, to automate this, what they did was they broke down the problem into 3 phases. So one phase was focused on image segmentation, and image segmentation is basically you basically draw bounding boxes on particular parts of the image. So it would draw bounding boxes around every individual product or deal on a flyer, and it built on something that Meta has created called SAM, and it found that it kind of over segments. For example, sees every individual grape instead of the whole bag. So segmentation involves basically breaking down your image into particular parts and draw bounding boxes around it. So when that happens, it might over segment. So what they did was they also did something called weighted boxes fusion. So instead of just picking the best box, they use this WBF to average out multiple overlapping boxes to find the most precise boundary. So I will not go deep into these because these are, what you have to understand is these are just computer vision techniques to pre-process images. So you remove noises and you segment and you detect contours, things like that. So this was your image segmentation layer. And after this after this phase one, they further used a layer of OCR with paddle OCR to read the text inside the box. So you got your images, you got your segments of products. So for example, in this, if you can see this part, just a second. Yeah, if you can see this part in weekly super savings, this huge flyer is going to segment out into, the apples bounding box, the bananas and broccoli bounding box, and you ingest those segments. After that, you need to still extract the text. What was the particular deal? You need to understand what was the price and what was the deal on. It was on apples and it's buy one get one free. So for that, paddle OCR was used to extract the text. For example, Honeycrisp apples at $1.99. So after this layer, an LLM was called that takes the raw text and the image to create a clean search query. So it separates attributes like brand, weight, and price. So search query probably involves, converting whatever text you extracted to like a JSON, and you had your brand and weight and price separation. So after this, they further fed this to a ANN, which is a nearest neighbor search algorithm. What it does is it simply scans their database to find the top 10 to 15 most likely product matches. And then after that, it would do they again plugged it to an LLM to compare the extracted attributes against the search results to pick the actual correct product. There was a final ranking layer, which was again connected to an LLM. So basically, instead of sitting and manually cataloging everything, they automated the whole process. So as soon as just a second. Yeah, so as soon as retailers uploaded flyers, it would segment and it would extract the deals with OCR, and then it would create a clean search query. It would search through their databases, understand what are the likely matches, and then do a final ranking to find the top match. So this was Instacart's use case. I found this very interesting because it required all computer vision to LLM plugging as well. The last use case I wanted to tell you was, apart from most of the models that we already know, there's one more model called, you might be aware, it's called SAM3. It's a segment anything model. What it does is, and a company called CVAT, which is a computer vision annotation tool, use this for data labeling. So they've transitioned from a manual click and drag tool to an AI-assisted agentic platform. So I think this is similar to like RoboFlow, if you've heard, where say you want to label a fish in all underwater video data set. So in the previous version with SAM2, you would typically have to initialize the object manually. For example, you have to click on the fish outline one by one, and then you have to keep reinitializing or correcting the model whenever new fish appears frame by frame. Okay, so instead of doing this frame by frame, where you have to keep tracking the object that you want to detect, with SAM3, you transform to a concept first labeling. So you provide a prompt that describes the concept like fish, or show an example, and the model attempts to find all the segments and all the matching instances across the video, and then track them as well as the video progresses. So this shift towards concept for segmentation, it opened up new possibilities for automated data annotation workflows. So the idea is, instead of repeatedly initializing individual objects with clicks or boxes, annotators can focus on defining what needs to be labeled while the model handles identifying matching instances. So yeah, it completely reduces manual effort and automates the whole process. So yeah. Finally, I just had some useful links to share with you to understand what are the leaders in Vision AI and stuff. So some of them are the Vision AI leaderboard by arena.ai. So it follows a public voting based leaderboard, uses an ELO rating system, and it ranks models by how helpful their responses actually feel. So in that, you can basically filter by price, votes, and the score, and you can also filter by categories based on your particular use case, whether it is captioning or entity recognition and stuff like that. And I also found this interesting, where they follow a rank spread instead of giving a direct rank. So Gemini 3 Pro can be anywhere between 1 to 4 rank. And another one was artificial analysis. It's an MMMU Pro benchmark. Basically, it is a benchmark on how well models understand multidiscipline reasoning. So this is another benchmark, and you can see breakdowns on various stuff like token usage and costs and results. And then finally, one more interesting tool was, if you want to get a feel of how these models are like, you can use RoboFlow, and you can basically add what kind of results that you're looking for, and add a couple of models, upload an image, and actually run the models output directly as well. So yeah, you can do object detection, OCR, captioning, and an open prompt as well, and also explore the models. It basically gives out two things. It tells you how much time each model took. That was the useful thing. And the second thing is, you can compare the responses of each model, how it fares. So yeah, this was more of a brief overview, actually, of all the vision model capabilities in 2026. Yeah. If you guys have any questions, I can take it now.
Folks, any questions? any of you working on documents or any kind of like vision projects, this would be a good place to discuss. Right. So, Abheetha, like, have you figured out any strategies for reducing hallucinations, especially dealing with documents?
Reducing hallucinations. Actually, I've not explored much.
Okay.
These are, problem statements I'm currently working on. So it needs more exploring. That's a really good question, though.
Yeah. So the one problem I'm working on is I work with financial documents for one of the projects. So I have done one is obviously there is filtering layers to make sure the document is correct and whatever. The extraction process happens. Then because of the cost, I can't use two LLMs and do comparisons, etc. But what I'm doing is I extract the entire data set, like table, and I do a manual mathematical computation of the values extracted and see if both of them match. So that's what I've done so far. But I'm still not like 100% sure at scale how this will actually perform.
Interesting.
Yeah. Gaurav?
Yeah, thanks, Bala. Thanks, Abheetha, for the entire walkthrough of helping me understand. This is super helpful. I wanted to understand, I work in a financial organization, and we have a lot more handwritten documents. For example, fixed deposits, we go into the interlinks, and at times our banking correspondent, they go and fill those forms. And then reading the files, and I think Bala mentioned that in a different way, but it's a handwritten files, but I'm not sure how can we best leverage it. We're trying to use Gemini Flash for that matter, but for cost effectiveness, but reliability of those texts is questionable. So do you have any suggestion? How do we go about it?
I mean, as far as I know, I might be wrong. Please take my suggestions with a hint of, a pinch of salt. So as far as I understand, LLMs are better at handwritten text understanding than OCR. And you have, if cost is your concern, you have SLMs as well from Qwen from Alibaba, which can actually still perform on a lot of documents at once. So you could explore SLMs and build a workflow with these open models as well, which are better at recognizing and analyzing handwritten text.
Got it. We'll try that, yeah.
I can share you some materials on it later.
Yeah, that'll be quite helpful actually. We can even put together some of this OCR related, like what are models, how do we approach it, etc. in a common place. I think.
Yes. I actually wanted to create one vast sheet of all the comparisons of all the models, and I couldn't get the time to do that. I will actually go ahead and do that and share it with the community. We can share it later on email addresses, which can be helpful for people.
Makes sense. Yeah, that'll help.
Yeah.
Okay. All right. Folks, any other question?
Yeah, I do.
Put something in the chat.
Okay.
Okay.
And there are quite a few actually. Any tips on how you pick model or approach for a fresh use case? This is from Vikram. Too many models to explore these days, too many opinions. I think the leaderboard is a good place, don't you think?
Yeah. The leaderboards benchmark, there's a lot of leaderboards. I mentioned only like one or two. There's actually a lot. And there's specific benchmark leaderboards for like particular use cases like OmniDoc bench and stuff. If you want to, explore which are the best models for document parsing and specific use cases like that as well.
Yeah, I'll probably get these links from you and we'll put it up in the.
Yeah.
Awesome. I think next is from Sid. Would like some insights on how a VLM can watch a YouTube video, specifically if I want to gauge emotions and unique expressions of speakers and make a list or persona that can replicate the unique communication nuances of a speaker. Okay.
if I want to gauge, I mean, I think that is quite a big problem statement.
I think so. Some tools are getting available. I've seen some.
Mhm.
I don't know how good they are, but a
Mhm.
friend of mine, what they did is there is an open source data. So this is a use case that they tried for capturing emotions of the client during a sales call.
Okay.
Are they distracted? Are they getting shocked, surprised? Are they
Right.
etc. So what they did is there is a human emotion data set that is available on Hugging Face.
Yeah.
Yeah. So they trained a custom model kind of like using that, and they said it was working reasonably well. But I'm not sure whether it is at a production level. So that's what I have seen. But there are a few platforms which actually allow you to do that. I'm not sure how. They work.
Yeah.
If this is something, if you could point me in the direction where I could look into this a little more, like Hugging Face is one which you told me about. This is something I'm interested in. Another hobby project I'm working on the side, where if we can train a model on 20, 30, 50 videos of a specific luminary and replicate their communication nuances to have an AI version of the same communicate to the youth. Something like that.
So actually, so you see, if the idea is to like these lot of these YouTube videos which are coming, right, like face replacements and other things,
Right.
right? Even today I saw somebody remade John Wick movie with Michael Cera instead of Keanu Reeves. Yeah. It looks pretty amazing actually. Yeah. Unfortunately, I'm not I have not spent a lot of time in that particular area. So I think best ways to do some research, but we can also drop a message in the community because some folks who have won AI Film Awards, etc., in the community itself, they will probably give you some tips onto that.
Yeah.
I can add here, Bala. So I've previously worked with Emotion AI, like in my mental health startup. So I use the API of Enable X platform, in which like it breaks down the emotions into three parts: valence, dominance, and arousal, and then it creates a emotion wheel based on where your parameters lie. So that can be a helpful tool for you. I've not worked with vision transformers for this use case though.
Thanks, VT.
Nice.
Yeah.
Awesome. Cool. Can you recommend any learning resources on VLM?
Honestly, you have to kind of, there's no exact learning resources. You'll probably find a handful of blogs. This is not a topic you'll find a lot of resources on, but the best resource to actually, get stuff is use Perplexity, use Gemini. They pull out actual web pages and you can learn from there. And I would suggest actually explore YouTube more. I found less written written text on these topics, more explanation in YouTube videos. I found a lot more, so explore YouTube more.
Yeah, and let's also choose an area within vision itself. There is like
It's a very big area.
Yeah,
It was quite hard to summarize the whole thing in one 2026 multimodal space. So yeah.
Awesome. Kanika, you want to go?
Yeah, I have actually put that in the chat as well. So I work in the cyber fraud space, and with deep fakes and synthetic identities being the rage right now. So KYC is becoming even more tougher. So just want to understand that how can VLMs be helpful or what can be done? You can share some insights here. I hope I was clear with it, or should I rephrase?
Yeah, I kind of got it. Actually, could you rephrase again?
Okay, so see, what happens is that in the financial institutions, or I mean, for businesses in general, like let's say for marketing purposes or marketing materials, there could be a deepfake video which can come up, right? Or a press release from a company, right? So how do we figure that out? That if it is, how a VLM could be helpful here, or let's say even for financial institutions, because we have clients who are from financial institutions as well. So they need to do a lot of KYC. But with deepfakes, this is again becoming a problem even for insurance companies, right? So just want to understand that how can VLMs, we can, leverage VLMs to cater to this problem set.
I mean, I guess the use case of VLMs in this context is that once you actually detect the deepfakes, you can kind of analyze what is exactly happening. So VLMs are going to be helpful because you can actually, I'm not sure actually how to respond to this, but VLMs are helpful. It's a connective layer everywhere to analyze your documents better, analyze whatever data that you have. It basically helps you analyze it better. It adds reasoning to just detection instead of just detection. So yeah.
So
Sure.
Kanika, I don't have a direct answer, but I'll give you an analogy of a use case that we were just doing it for as a POC for one of the clients, right? So you see these fake damaged products being sent to Swiggy and Zomato customer supports for refunds, right? So these are all AI generated. So one of the ways we did a POC for that is to create a simple detection model by generating a lot of these fake images and teaching AI how to detect between a fake and a real image, right? So we just like fine-tuned a neural network to kind of like do that. It actually did about 97% accurate, right? But the problem with this is these models are getting, like the models which fake this are getting more and more realistic on a daily basis. That means you will have to continuously put in the effort to do this. Yeah, that is the one viable area or I have seen so far to kind of address this problem.
Sure. Okay. Would love to have any materials, resources to, just go through it.
Yeah, see, I don't know what, it's a simple detection model. We can probably connect after this call and I can run you through how we did that.
Sure.
Sounds good. Ishwadeep.
Yeah, hi Abheetha. So I have a product which makes presentations, like it's a PPT maker tool, right? So in this first layer of inference is on creating an image, then creating some text, and then the last layer is on judging that. Like, so in the evals part, I can judge the text, whether text was created appropriately or not. But there's a visual element also, that let's say I have a diagram on the PPT and whether the text is fitting in that diagram or not. So that is where it usually fails currently, that maybe like it is detecting based on bounding box only, and maybe the image is, let's say the diagram is circle. So it still creates a bounding box, rectangular bounding box, and the text is little overflowing sometimes. So is there any way I can improve this through prompts or through model selection itself rather than training a model from scratch?
Yeah. So the abilities of VLMs is it doesn't just draw bounding boxes. It has more spatial reasoning. So instead of just using a model which does detections, you could plug in LLMs to actually, improve this process. There must be a way.
Okay, so you're saying like I need to refine prompt based on some certain like spatial like directions. Is that how?
So what is your current architecture like? Like, what do you exactly prompt?
Flux Pro 2 Pro is the image generation model.
Okay.
And LLM is ChatGPT 5.2.
Okay. So I'm not sure exactly how Flux Pro works. So you would have to look into that actually. But I'm sure there is a better architecture that you can perform here. That
Sure.
is all I can say. Yeah.
All right. Yeah.
Bala might have more insights.
I've also not worked on the Flex Pro models. I also didn't fully follow the, sorry, I was doing something else, my bad. But we can probably connect offline and we can discuss.
Sure.
So Bala, I guess like there's a lot of questions that didn't get appropriate answers. So we can make a note of the questions. I will do like a research on it and we can mail or connect with everyone.
That'll be good. Yeah.
Yeah. I promise you I will do some good research on it and get back to you with the solution.
Yeah, of course.
Yeah.
So, cool. Jan Priya, yes.
Trial.
Hello. Do you have a question, Jan Priya?
Trial.
Yeah, I'm not sure what is happening. Probably it's an AI bot.
It seems like it.
Yeah.
Trial.
Sorry, I'm not following what's happening. Okay.
Yeah.
Trial.
Yeah, if you're saying something, can you talk?
Or maybe they can just put it in the
You can just put
chat.
it in the chat box. That will be easier. Yes. All right, folks. Any other questions? We're almost on time. Yeah, I think they're writing it. Yeah. Super. What we will do is after this call, we will obviously we'll get those questions. We already have the whole thing recorded, so probably we can address that. We'll also put together some material and share it with the group, so it becomes useful. And we'll also have the video posted on YouTube in a couple of days. Okay. Yeah, I'll probably drop in my email. Yeah. Okay, they're working on a PPT builder.
I mean, the problem statement is not that.
Yeah. Can you share the problem also? What is the problem you're facing?
Trial.
I'm sorry, we're not following this. Why don't you do one thing? Why don't you write to the email address I've shared earlier? We will actually respond to this.
Trial.
Yeah.
Yeah, that would be better, I guess.
Awesome. Thanks a lot, Abheetha. This is quite great. I think what we've been wanting to do a session on vision for a long time, and I'm very, very glad that we're able to do a good session on this. TK folks, thanks for joining on a Saturday. Really appreciate it. If you're interested, join the community, and see you in the next session. Thank you, everyone.
Thank you, guys.
Bye.